Fit. Fit. Okay, here we go. So we are jumping up to 12-1. We're gonna have. When did we say we're gonna have a mid-chapter assessment?
Tuesday.
Tuesday, right? Didn't we vote on that? Yeah, we voted. So mid-chapter assessment. Mid-chapter assessment on Tuesday. So we're jumping into 12-1. So for today, one of the things I want to cover is we're talking about solving quadratics. That's what we're working on. So in solving quadratics, okay, a quadratic really?
Unless these are too long.
You guys may be in business.
Yeah. Business is good.
Oh, it's a close one.
That. Now. No. If you can go find 4 washers, that'll keep it from going all the way in. And,
4
Okay.
okay.
I will do that.
So solving quadratics. Remember, a quadratic is something that is being squared. So that's the general quadratic look. That's the general quadratic equation. We have 4 ways to solve quadratics. We learned one of them yesterday, Wednesday. The 4 ways to solve quadratics. The first way we worked with, at least in this review, is factoring, right? So we set the equation equal to 0, you factor, you set each factor equal to 0, and you solve. So that's the methods of factoring. The second way that we're going to work on today is what we call perfect squares. Okay, perfect squares is the second method that we learned how to solve quadratics. So, hey, Mr. C.
What do you mean you're too long?
Okay. Do you want to come up?
Well, I'm embarrassed.
They will be happy if you prove me wrong. So it's got to go on here. And if we screw it from the back, I think it's going to poke out. Because the way the, it's just like this one. The way it's set up. This pokes out. Does that make sense? It's got 4 little holes. We probably actually don't have to put them all the way through if we don't have washers.
Yeah.
We could just put them where the head just stays instead of poking through.
How many washers?
4, but we could probably do it without. Oh, I mean, I think if it was gonna poke out, it was just gonna be the tip of it. So,
2
maybe,
washers each?
no, 1 washer each should be enough.
On top of your car was locked. There's a lot of valuable stuff inside. Dirt, old french fries and stuff like that. Anyways, your mom's handrail.
Oh, their handrail. Oh, from my house. Yeah. Awesome.
It's all welded up and ready to go.
And that's the one that goes on the fence.
Yes. And it's
Do I need some leg screws to go to
there's 2 monsters. It's like
4 inches or probably longer?
whatever you choose.
I think I have a couple 4 inches in this for the track. Oh, really?
You just gotta get through the soft cedar.
Yeah.
And then you're into the 4x4.
Right, right.
So that's
Whatever that is.
2 inches you find, 2, 3, 4.
Are you gonna be here after school? Or are you getting ready to head out?
No, I'm already on.
Okay. That's fine. Walker can put the handrail on my car.
Well, I didn't want to break the window, where you want that.
Well, I don't know what I'm gonna be doing with the car and the windshield wiper. Switch. $1,000 to replace it.
There's other ways. If you
I know.
Some Indians did it.
That's how I'm gonna do it.
How are you gonna do it?
Okay, what's my task?
Your task is go with Mr. C. You're gonna put the railing in my Subaru.
Okay.
You can just open the trunk for the Subaru, yeah. Then he's gonna give you 4 washers.
Sweet.
And then, will your shop be open to get that drill back? Cause you're gonna be gone. Oh no, I can put it back after school. I've got the code. 3794.
Okay.
So I can get that back, or I'll have it here when I'm dressed.
You got an hour to sleep.
I'll just add it to all the other tools I borrowed from you, and I still have in my house. It's awesome. I keep on the tools. Yeah, I've got this like selection of tools from Mr. C, and I'm like, you know what? His mind's going just enough where he doesn't remember I have them, and then he'll probably pass away pretty soon. And I'll acquire some nice set of tools.
I'll be sending this YouTube video.
So. I would say I'm kidding, but. See, if you do watch this, I do have your jigsaw, the DeWalt jigsaw still. Alright, so here we go, number 3. So perfect squares we're going to deal with today. And then I'm going to have the other ones completing the square. And that one doesn't, we will practice it. And that one gets used a little bit like in pre-calc and calc. Doesn't really get used in geometry. So that's one of those like deep breath. You'll have to do one of them on the test or something, but won't have to produce a bunch of it. And then 4 is the quadratic formula. That's a general one that most people probably know, and you should know. That's the x equals negative b plus or minus the square root of b squared minus 4ac all over 4a. 2a, yeah. So we'll cover that one later as well. Okay? So those are our 4 ways: factoring, perfect squares, completing the square, quadratic formula. We've done factoring, check. Now we're going to do perfect squares. Perfect squares you've actually kind of done a little bit of already. I can't remember what lesson it was, like 11-7 or something like that. But a perfect square, okay, we're going to solve. Let's just start with number 1. If you have x squared is equal to, we'll pick something straightforward, 16. We call this perfect squares because we do not have to, like right here, we don't have to do a manipulation and we don't have to factor it right now. We can, since it's x being squared and there's no other x involved, right? It's not x squared minus 5x is equal to 16. If that was the case, you can't just take the square root like that because you got the 5x that needs to be dealt with. So that doesn't work. If it's like this though, what have we done? We already did this in like 11-7. You just take the what of both sides, the square root, and whenever you take the square root of both sides, it's critical to state, plus or minus, right? And then you get out 4. So this is really nice when it's perfect squares that look like that. They will start to look a little bit harder though. They'll look like things like this. If you have x minus 7 squared is equal to, let's say, 100. Okay, we can recognize, so there's errors that occur with this. One error is that people, they distribute the exponent in. That's mathematically wrong. The other thing, it's not an error, but they take x minus 7, don't write this, but they say x minus 7 times x minus 7, and then they FOIL this all out together, they subtract the 100 over, and they go through a factoring method, which works, it's just a lot of excess work. This falls into our perfect square category because I have a quantity being squared. When you have a whole quantity being squared, what can I do to both sides? Take the square root. When you do that, okay, we say plus or minus 10, and then it's just x minus 7. You add the 7 over. Now we can't leave it like that because we can combine 7 and 10, right? What's 7 plus 10? 17, and then 7 minus 10 is negative 3. So you have your 2 answers there. So we really like it when it's a perfect square setup. You just take the square root of both sides. You're going to see some that you have to do a little bit more manipulation to. Let's say you have a 5 times a plus 4 quantity squared is equal to, let's pick an easy one for us,
64.
125. Okay. 64 we could do, it would just be a little more, we'd have to deal with radical. We'll pick one with 64 as well. Okay. Alright, so this, 2 errors occur. Well, maybe it's just 1 error. 1 error, 2 errors occur. 1 error is people distribute the exponent in. You can't distribute into a binomial. That's mathematically wrong. Another error, they do 5 times a, 5 times 4, and then they square it. Can't do that, okay? So you can't distribute that in because you have to go parentheses, exponents, then multiplication. So pro tip, get rid of the 5 first. Is there anything wrong mathematically with dividing both sides by 5? There isn't, right? I can go like this, and then I have a plus 4 quantity squared. What's 125 divided by 5? 25. So I made it nice and easy for us, right? So that we get a perfect square. You don't have to have a perfect square. We'll do some that are not perfect squares on the right side. And then once you have this, once you have your quantity being squared, again, you don't want to take the square root until you've isolated it. So a plus 4 is isolated, and now I can take the square root of both sides. A plus 4 is equal to plus or minus 5, and then I subtract the 4, and then I get out your negative 9 and positive 1, like that. Okay? So isolate that perfect square, then take the square root of both sides. Okay, we have a few more examples that I need to make sure we give so that we can see some other things. Now these have all been really nice. 16 was a perfect square. 100 was a perfect square. 25 was a perfect square, right? Well, what happens when you end up with one that isn't a perfect square? Let's go with this. 7m squared minus the square, minus 42 is equal to 0. Okay, this almost looks like a factoring one. I was working with Khalib at lunch about some factoring stuff that kind of looks something like this. Okay, we recognize it is missing the middle term. Don't write this, but you know, it doesn't have something like this. It doesn't look like that. If it looked like that, then we'd look at factoring. Okay, it doesn't have that m term in there. It's missing the linear term, right? So if it's missing the linear term, it's set up for success for us with isolating the m. And you guys have already done these in like 11-7. You just add the 42 over, divide by 7, and you would get out 6. So isolate the perfect square, then take the square root of both sides. Now in this case, the book is not going to ask for decimal answers. They're going to say leave as a radical. So the square root of 6 is just the square root of 6. We're not turning it into decimal format. Just leave it there. Again, whenever you take the square root of both sides, you have to say what? Plus or minus. You're going to miss some points on the test again, or the mid-chapter assessment, forgetting to do the plus or minus. Okay, let's do this one. Let's do this. Number 5. 6 times z plus 5 squared is equal to 42. Now this one is very similar to something we just did, but I set it up for us so that we can work with a non-perfect square on the right side and see how our answer looks without a calculator. So again, the error is going to occur. You distribute the exponent. Wrong. You distribute the 6 in. Wrong. What should I do with my 6 to start solving this? Divide. Yeah, so we say, I can get rid of this. You know you're going to have one on the test like this. Well, maybe you don't know that, but I'm warning you. You probably will. Because it's always like, it's not fun, but it's like, oh yes, they foiled the whole thing out. They distributed the 6 and they subtracted the 42. They tried to factor it. I'm like, oh. I wish they would have just listened. Which was pro tip. Divide by 5, take the square root. Pro tip. Okay? Divide by 6, take the square root. Now this one, the reason why I put it in here, it's a little bit different, is that 7 is not a perfect square, so we leave it as the square root of 7. We're not asking for a decimal answer. So what we're doing is we're going to subtract the 5 over. So there's 2 ways to write it. One is optimum, and that is the negative 5 goes out front. Any suggestion why I bring the negative 5 out front instead of on the back end? Katie. Yeah, you bet. Otherwise, this happens and you have like that. And the question is, you might mess it up and go 7 minus 5 is 2. It's a possibility. Or I look at it and say, well, is the 5 underneath or not? I don't know. So that's why we bring it out front. If you went like this, just like that, I'm going to give you credit because that's clear. It's not underneath the radical, so you're fine. So if you want to bring it on the back end, that's fine. Just make sure that square root doesn't extend over there. That's our answer. We're not doing any decimal formatting. If we were, you would just take your calculator and punch in negative 5 plus square root of 7, enter. Negative 5 minus square root of 7, enter. And you'd have 2 decimal answers, which we are not doing. Okay, then we get to one that's going to break away from what our look has been. And our look has been, we keep seeing perfect squares already given to us, which is awesome. Now we hit this, and I'll give you a tip here. Here you go, Harry. 64. You wanted that in there. I got it in there for you. Okay, I'll give you the tip here. The tip is on the test. I'm not going to say you must use perfect squares to solve one like 6. I'm not going to. I will say solve with factoring. I will say solve with completing the square. And I will say solve with the quadratic formula. So this one, if you don't recognize the perfect square formatting, it's actually okay. You can either do quadratic formula, you can factor it, you can do completing the square. But this one falls into the perfect square category. Remember, perfect squares is I get something squared, I take the square root. Something squared, I took 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 the square root, right? We cannot, like I've already stated, right? Because that is not just x squared. It's x squared with this other stuff going on. So I cannot do that. I need to get it to just something squared. Why does this fall into our perfect square formatting? Is it? Jamie. Yeah, 7 and 7. So if you factor this, okay, you get minus 7 minus 7. What's x minus 7 times x minus 7? Yeah, then we get x minus 7 what? Squared is equal to 64. Okay? So then, now are we to our perfect square formatting? Yeah. So now we take the square root and we get x minus 7 is equal to plus or minus 8, like that. And make sure, if you can combine, like here with the radical, we couldn't combine, we left it. Don't make that little error that people do and they say like, oh, 7 like that, and they leave it. Because we all should be able to do what's 7 plus 8? 15. What's 7 minus 8? Negative 1. So x equals 1. Notice how many answers are we getting for all of these? 2. Yeah. And that will continue unless you hit a double root, like Nate was kind of referring to in the homework. Okay, we've got, I think we can get away with like 3 more examples, and I think you'll mostly be covered with everything, and then you should have plenty of time to work on this. And if Walker and I can successfully fix the whiteboard before the end of class, we will, as promised, have 2 rounds of gambling. And so let's go with this one. Here is a Classico. Okay, x squared plus 47 is equal to 15. Okay? So you're like, wait a second, this is right back to our kind of basics of what we're doing. Usually we progress and get a little more complex, and we're swinging back into, this looks kind of basic. So what would my first step be to solving for x squared? Isolate, right? So subtract what? 47. Okay, so we subtract the 47, and I get out negative 32. Okay. Then I do what? Take the square root. So then you take the square root. Ah, good. Somebody said wait. Who said wait? Why no? It's a negative. Can you take the square root of a negative and get out a real answer? No. So it's going to say only real answers work. So if you have a square root of a negative, not a negative on the outside, but a negative on the inside, this is Fruit Ninja, right? No solution. Fruit Ninja. Is that's still a game, right?
Yes.
I played it once. That was like 15 years ago, like when iPads first came out. You know, it was like Fruit Ninja. And it's still a thing.
Yeah.
So this is the no solution symbol. You can write the symbol there, or you can write no solution, no real number. If you just leave it like this, you will lose you'll lose 3 points. I'll give you 1 point for at least subtracting and taking the square root. But it's no real solution, so you need this and not that. So if you see a problem, you don't have to write this one if you don't want. If you see a problem like this, -1/4, you're not going to have to do any work. Because you know when you take the square root, you're going to be taking the square root of a negative. So pro tip is don't do a bunch of work, say, square root of a negative, guess what? Not going to be duped today. No solution. Okay, 2 more examples, and I feel good about setting us the task with plenty of information for solving most of the problems. If you have, let's say you have yes. What are we on? Number 8 here, I guess. There we go. 0.49x squared, and then plus 2 equals 3.96. Why does this one look like confusing? Decimals. Do you solve it the exact same way? Yeah, you bet. So a couple options. One option is I can multiply to get rid of the decimals. What would I multiply by to get rid of these decimals? 100. Some people say 10, that's okay, but we're actually dealing with the tenths and the hundredths place. So you need to multiply by 100, you get rid of the decimals. You have a calculator in hand. Feel free to use the calculator. There's no shame in saying, I'm going to subtract 2, divide by 0.49, right? So you could do that as well. If it's uncomfortable, you can get rid of by multiplying everything by 100 and calling that 200 and calling that 396. So either way is acceptable. There's nothing unique about the problem. It's still just going to be isolate the x squared and take the square root of both sides, okay? So either way, you can either do it with the decimals, or you could just do it without the decimals by multiplying everything by 100 there. And what do you get? 196. If you did it this way, 49x squared is equal to 196. And 49 goes into 196, a nice, cool, smooth, how many times? 4. I'll help you out since most of you aren't doing any of the work. And then x is equal to plus or minus 2. Okay? Let's do, I know I said only 2 more. Let me do this one last one. Always throws in confusion for people. X plus 4 squared is equal to 0. Why does this one cause confusion? There's a 0, right? So, take the square root of both sides. What's the square root of 0? 0. 0 is neither positive nor negative, but if you really wanted to, you know, if you're like, it's plus or minus 0, well, it's still 0, okay? So when we go to solve, you're going to add 4 to both sides. 4 plus 0 or 4 minus 0 is still 4. So you only see one answer. There's really 2, but in that case, you're just going to see one answer there. So people, there's a problem in the homework, I think, that's set equal to 0. People get confused. Hopefully that eliminates any confusion. Okay, this one is the last one, so number 10 here. You're going to have a problem that says 1/4 t cubed minus 16t is equal to 0. So this one, why does this one look a little bit unique compared to our other ones? Cube. Yeah, you bet. It's not a perfect square, so don't take the square root of both sides. So,
So, number 9, why would you switch the,
oh,
to a negative?
you wouldn't. Sorry, that should have been 4.
Oh.
I think I was going for the answer of -4. Good question. I had an error here, if you didn't see that. Sorry, that was a negative. Let me erase it. This was my error. So Nate picked up on that. It was x plus 4 squared. We took the square root. This should have stayed positive. That was an error on my part. So that would stay positive. And then you would subtract the 4 over, so then the answer would be -4. Thank you for catching that. Definitely you're not doing any sign switching in there. Definitely not. So a good catch on that. Okay, switching over to 10. On number 10, you can't take the square root, but what you can do is take out what they have in common. Or if you don't like the fraction, what can we do with the fraction? Multiply by the LCD. What's the LCD in this case? The least common denominator is 4. So if you want to get rid of it, it's no problem. Multiply everything by 4. That goes in here and here. So 4 1/4 is just t cubed. 4 and 16, Harry, there's your number. 64t. 0 and 4 is 0. Okay? So that's a good way to get rid of fractions, just multiply by the LCD. Now, the issue is I still have a t cubed. So we look though, guess what? I have a t cubed and I have a t. So what do they have in common? T. So what can I pull out front? T. Now, why then does this fall into our perfect square category? Well, they set it up for you right here. They said, hey, factor out the t, and now I have 2 factors. I can set them equal to 0. Just like we were working on, so t equals 0, and then t squared minus 64 equals 0, right there. And now I have a basic factoring perfect squares problem. T squared is equal to 64, t is equal to plus or minus 8, right there. Some of you may recall from factoring, that's what Cleve and I worked on actually, was a difference of squares, if you recall that from Algebra 1. We're not reviewing difference of squares, but some of you may recall that a t squared minus 64 factored out to be t minus 8, t plus 8. If you remember that, that's a fine way to go. We won't hit it up in geometry for factoring. So, but that's something you can do to factor it if you want. Otherwise, perfect square method, bring it over, take the square root of both sides. Okay. Questions, comments, concerns, emotional problems? All the time. Yeah. So there we go. We're going to pause there. You have the remainder of the time to work diligently on math. Remember, we'll have a mid-chapter assessment, so you can review anything that you need to for that for Tuesday. And then you should hopefully get your homework done, working together, helping each other out. Yeah.
What number can you use this one?